Hello everyone, this poster shows the study of the photodegradation effect of rosin films irradiated with UVA light. The motivation for this study is that rosin is a natural resin obtained from the exudation of pine oleoresins, consisting of resin acid of the abatic and pimatic type, which are susceptible to photooxidation reaction by incidence of ultraviolet radiation. These types of acid confer excellent properties in the formation of films, coatings, and microencapsulation. It is worth mentioning that the radiation that most deteriorates the properties of the polymers is UV light, which is why their degree of degradability is determined in order to assess their function of use under condition with this type of radiation. Thus, in the present work, experimental results are presented of the study of the degradation of rosin films at different exposure times with type A ultraviolet radiation. The characterization of rosin films before and after exposure to UVA radiation was carried out by means of weight loss analysis, optical microscopy, Fourier transform infrared spectroscopy, and contact angle. As a result, weight loss. Thinner films showed a higher degradation compared to thicker films, irrespective of whether they are irradiated at 395 or 365 nanometers, with increasing radiation energy that is from 395 to 365 nanometers. The degradation is higher regardless of the thickness of the films. Additionally, 0.5 micrometers films irradiated at a wavelength of 395 nanometers and 365 nanometers result in a wave loss of 8.8 and 70.4% respectively. Optical microscopy. For the monitoring of the morphology of the rosin film exposed to UV radiation at different times, the optical microscope was used to determine the signs of the degradation, whereas it's observed that the thinner film shows a greater discoloration than the thicker ones, due to the increase in exposure time and independently of the radiation. Figure number 2 shows that in the last exposure times, more than 20 days, the presence of morphological change on the surface increases, such as surface imperfection ranging from small lines of material loss to holes in the sample. This indicates the high interaction of UVA radiation at 365 nanometers with the surface, which coincides with the results obtained previously for weight loss, where a higher radiation energy shows a greater effect on weight loss. The color change from an intense to a lighter shade was more evident after 30 days for 395 nanometers and after 20 days for 365 nanometers. FTIR. One of the methods for studying the progress of photodegradation is rosin films. Is by analyzing the carbonyl and hydroperoxide groups by means of infrared spectra. Figure number 3 overlies all IR spectra obtained from rosin films irradiated with UVA radiation at 395 nanometers and 365 nanometers. The films not exposed to UVA showed the group carbonyl vibration at 1692 wave number lower frequency, and as time elapses, the band is gradually shifted. The carbonyl band is observed hydroperoxides in the range of 2800 to 3000 wave number lower frequency and 1500 to 800 wave number lower frequency. In the photooxidation process can reach a maximum point for 15R 365 nanometers and 30R 395 nanometers, where variation occurs prior to the energy transfer that exists in the functional groups. At 5 days of exposure, there are change in the vibration of the hydroxyl groups, a stretching between 3600 to 3300 wave number lower frequency. At a 15 days of exposure at 365 nanometers, the stretching of the hydroxyl is more intense. Thus, this FTIR analysis of rosin films shows the deterioration of rosin samples under the action of UVA ultraviolet radiation, particularly at 365 nanometers. Contact angle. An increase in UVA exposure of the films produces a progressive decrease in the contact angle at shorter wavelengths, result in a more hydrophilic surface reduced angle, which is probably due to the presence of hydroxyl groups, surface oxidation of the fields. In addition, the degradation information of surface polar groups is more intense on thicker samples with higher energy irradiation sources. In this sense, lower energy radiation sources have a greater tendency to generate degradation of hydrophobicity in thinner samples. Conclusion: UVA radiation altered the physical and chemical properties of rosin. A reduction in weight attributed to chain season, a change in coloring, a decrease in contact angle, and increase in a carbonyl group signals as a function of radiation exposure time supported the alternation produced.